All right, this is going to be a quick video. You really just need to memorize these functional groups that are present on table 2.1 that can be found within, looks like slide 17 and 18 of the PowerPoint. You would also find these in the textbook. But I want to go through and run down a couple things and give you some ideas on how to group them and how you might be tested over them. So first of all, I want to start off with the letter R. R is a common shorthand in organic, and basically it's just this is the rest of the molecule. All right, so for instance, our first functional group is going to be an let's actually start with alcohol. All right, okay, so an alcohol is an organic compound that has the functional group OH in it. All right, so this is an alcohol. Now, this is a generic alcohol. Specific alcohols might look like this. This is methanol, right? Here is a benzene ring with an alcohol in it. The CH3, the benzene ring here, those are both specific R groups. So whenever I give you an example and ask you to identify functional groups, I'm not going to put the letter R, usually. I'm going to give you a specific molecule, maybe a pentanol, right? All of these are alcohols. The alcohol is the OH group. The R is the rest, right? And so sometimes R can be really useful to allow us to focus in on a functional group. But for here, it's mostly just a placeholder so that we can learn the functional groups. All right, so that's our first one, alcohol. We also have something called an alkyl halide. Now, this brings in another abbreviation. That's why I didn't want to start with it. R is the organic. X is going to be a halogen. All right, so this could be fluorine, chlorine, bromine, or iodine. Fluorine, chlorine, bromine, and iodine often behave very similarly. So we'll frequently see X if the chemistry is going to be similar for those four elements or some combination of those elements. This is an alkyl halide. We're going to see this term more and more throughout the semester. It's based on alkane, which is just a simple carbon-based compound. So alkyl halide and alcohol. Those are your first two. So if we saw a specific alkyl halide, I guess before I move on, let's say we had maybe a 5-carbon chain with bromine in it. That would be a specific alkyl halide. You may hear it called an alkyl bromide because it's the specific halogen is bromine. But this is how you might see the difference between sort of an abbreviated form versus a specific form. Moving right along, we're going to see single bonds all the time. Single bonds, we're going to learn, aren't terribly reactive between carbon. But double and triple bonds have different functionality, have different reactivity. So we group them as their own functional groups. A carbon-carbon double bond is an alkene. And a a carbon-carbon triple bond is an alkyne. Chapter 7 and 8 will really focus on alkenes. Chapter 9 will focus on alkynes. So we'll be talking about that quite a bit this semester. Now, the alkene is a broad term for any sort of carbon-carbon double bond. I'm kind of skipping around the chart here because that's how my brain works. A specific type of triene, right, is based on the benzene ring. It's a 6-carbon ring with 3 alternating double bonds. And you see that here kind of at the bottom of the chart. This is known as an aromatic group. We spend 2 chapters in Organic 2 talking just about aromatic structures and their reactions. So, for instance, lots of different organic compounds have aromatic structures within them. For instance, we saw amoxicillin earlier in our slideshow. I really decided to go way back here. And you see it has, if we started naming functional groups, one that we see is an aromatic ring, and there's an alcohol. Right? So it's a common functional group that has alkenes within it. Okay, now, speaking of, let's see, functional groups within functional groups. Actually, let's do ethers before we move on to that group. When you have an oxygen that is between 2 carbons, so between 2 basic R groups, this is called an ether. Now, it's specifically going to be some kind of carbon group that does not have a double bond to oxygen, and that will be relevant in a few minutes when we see another similar functional group. So kind of your most basic types of ethers might look like diethyl ether, right, with 2 carbon chains on either side of the oxygen, but it doesn't have a hydrogen. That's an alcohol. Right? It doesn't have any sort of double bond directly on this carbon, right, on either side. Now, there can be double bonds in different groups further away, but that carbon right next to the oxygen's got to be pretty basic, pretty simple. I got to stop saying basic because we are going to talk all about acids and bases in the next chapter. Now, thinking about functional groups within functional groups, I want to talk a little bit about the C double bond O. This atomic structure, these 2 atoms bonded in this way, are part of several functional groups. And so very generally, this may be referred to as a carbonyl. And the carbonyl, when we say carbonyl, this is never going to be specific enough. So when I ask you for the name of a functional group, you aren't going to give me carbonyl. This is really important for communication, for us to talk. When I say something about a carbonyl, I want you to know what it means. But each functional group that contains the carbonyl, we're going to get more specific with what's on either side of that carbonyl. Okay, so functional groups that contain carbonyls. If the carbonyl is between 2 R groups, this is a ketone. Right, so 2 carbons, a carbon on either side, that's going to be a ketone. Specific ketones, right? The simplest one is acetone, where you just have CH3s on either side. But those R groups could, have however many carbons. They could be aromatic, right? What the R group is doesn't matter as long as it is a carbonyl sandwiched between 2 organic pieces. Please don't judge my battery life in this moment. Thank you. Okay, next, very closely related to the ketone, is the aldehyde. Aldehydes have a hydrogen on one side. And so they're similar to the ketone. They have similar reactivity to the ketone. We'll do a chapter on just those 2 in Organic 2. But that is called an aldehyde. If we have a hydroxyl group, and so we'll talk about that word in just a second. This is a carboxylic acid. Carboxylic acids have an R group on one side and an OH on the other. So an OH by itself is an alcohol. A carbonyl connected to an OH is a carboxylic acid. So you remember I told you that the C double bond O is sometimes referred to as carbonyl. The OH, without knowing what else it's attached to, can sometimes get the name hydroxyl group. But specifically, hydroxyl groups with an R are an alcohol. Hydroxyl groups with a carbonyl are specifically carboxylic acids. If we replace that hydroxyl group with a halogen, we get something called an acyl halide. Depending on the book, depending on the day, for me, I may also refer to it as an acid halide, right? Either one is correct. I won't ever try to trick you with those two. But it'll be either an acyl halide or an acid halide. Notice that's different than alkyl halide, right? Our alkyl halides over here is just a regular R group, so no carbonyl with a halogen. Our acyl halide has that carbonyl group and the halogen. There's lots of synonyms in organic chemistry, and acyl is related to carbonyl. Remember I said with ethers, the carbon had to be very simple on either side of the oxygen. Well, that's because if we have a carbonyl on either side of the oxygen, that's an anhydride. Sometimes they're called acid anhydrides, but there's always the word anhydride. And these behave very differently from ethers. And so this is a different functional group, right? We're categorizing these common groups of atoms because they often behave in similar ways. Rather than learning every possible reaction for millions of organic compounds, we can study groups of compounds and predict how they'll behave. If we replace the hydrogen in the carboxylic acid with an R group, we get an ester. All right, so it's kind of like halfway between an ether and an anhydride. It's an ester. If we replace that with a nitrogen, and I'm going to just put 2 lines here. This is an amide or amide. I've heard it both ways. I'll say it both ways. Pick your favorite. Now, I just put 2 lines coming from the nitrogen because it could be R groups, it could be hydrogen. It doesn't matter, it's still an amide. So nitrogen forms 3 bonds. Those 2 other bonds, whatever they are bonded to, it's still going to be in this category of amide. I believe that is all of our carbonyl-containing functional groups. So I do want to take a minute to talk about nitrogen functional groups. Now, NH3 is ammonia. You learned that in Gen Chem. But if there is any R group connected to it, it's an amine. Now, it could be 3 different R groups. It could be 1 R group with 2 hydrogens on it. That's also an amine. All right, so as long as there's at least 1 carbon attached to the nitrogen and it's not a carbonyl, it's going to fall in this category of amine. And then there are 2, excuse me, there are 2 sulfur functional groups that you need to know. The sulfur derivative of the alcohol is a thiol, and the sulfur derivative of an ether is a sulfide. I highly recommend you making some note cards or writing these in a list over and over again. Whatever you need to do to memorize them, I recommend you do that early. It will be on your week 2 quiz. It will be covered on your exam. And it will be important for communication for the rest of our semester or year together. I just wanted to put this in one little short video by itself. In the next video, we will get into formal charges and introduction into resonance.